So let everyone in. Happy Wednesday. Thanks for everyone for being flexible. I know that we moved yesterday's all team call to today. We're going to talk all things science, all things Luma. We're going to go over as much stuff as we can um, as we're continuing to let some people in. We'll get rocking and rolling. Hopefully, you got pen and paper or you're taking notes. Write down your questions. We will probably have a follow-up after this. So we want to, obviously, Tyler is going to be presenting. And today's not going to be a Q&A. We're not going to have a Q&A today. It's going to be probably, it's going to take all 1 hour, 60 minutes. Sorry, not 1 hour and 60 minutes, 60 minutes. It's probably going to take that entire time. And so we'll probably the goal is to start doing more of these with Dr. Tyler and to maybe have a Q&A call in the future where we get some of our questions answered, where we have the ability to ask him about his research. And he is not going to send you to MHI Institute to take one of his courses. He's going to help answer your question on the call. Nicole got the joke. I see Nicole laughing, so Nicole got it. So awesome. I Perfect. Everyone ready to go? Giddy up. Let's get started. Chris, keep an eye on um, people coming in in case I miss them. All right, ladies and gentlemen, I am so honored to bring to you the fabulous Tyler LeBaron, who is the founder and executive director of the science-based nonprofit Molecular Hydrogen Institute. Tyler's background is in biochemistry, physiology, and exercise science. I also learned yesterday that he's teaching at the college where he lives, which I don't know how he has time to do that. But he has taught physiology and currently teaches, chemistry labs classes at Southern Utah University. He interned at Nagoya University, Japan, and the Department of Neurogenetics to research molecular mechanisms of hydrogen gas on cell signaling pathways. I think we refer to him as the GOAT or the man that knows all about molecular hydrogen. He is a wealth of knowledge. And if you haven't heard any one of his numerous amounts of podcasts where he really talks about his research and what he's done, I highly recommend it. There's a few that I would definitely pin and point out and listen to because he has a way of being able to explain the science in a very accessible way to understand, and it's in bite-sized chunks, and that's why I think I love working with Tyler. So without further ado, Dr. LeBaron, you have the floor, sir.
Amazing. Thank you, Patrick. That's my honor, pleasure to be here again, educating everybody. It's wonderful to see many of you. I see some of your smiling faces, so that's wonderful. Makes me happy to be here to educate you. So this is exciting. But yeah, I am teaching at the university this semester. It's an extremely busy semester. I'm doing like 100 plus hour weeks because that's on top of all my other stuff that I'm doing right now. But I really do enjoy teaching, and this semester I'm teaching the advanced exercise physiology class, which is something I really love to do. The other professor is on leave, and so this is like a once in a lifetime opportunity for me to teach this one because I'm not full-time professor. I kind of just help with teaching in the departments as I am able to, and so this is a great opportunity for me, and so I decided to go for it. And so here we are, and. I'm that's why I'm also here to teach you guys because I do love to teach. It is fun. So I did prepare a little presentation to kind of guide some of our thoughts a little bit. Let's see here. Let me pull this up. Okay, this is my presentation here we'll talk about. So it is molecular hydrogen. Let me move these. Let's see if we can. Oh, let's see. How do we? Okay. Um, just trying to figure out how to get this set up just right. Oh, now we just lost it. Wait, do you guys still see my screen?
We
No.
do. We still see you. Are you trying to move everyone's
Yeah, I was just trying to
faces?
move. Yeah, I was just trying to move the faces
Go up
here.
to the top right to where it says view on your screen and click view, and you can change You can do standard view so that they're out of your way.
Yeah, I just see it just shows the show some thumbnail, but it's okay. Right. All right. So yeah, I will say I'm going to tell you why I think hydrogen is good for you. I do have a potential conflict of interest. I am a scientific advisor to Lumavite, as you know, and but I appreciate that Lumavite wants to understand the research and the science behind molecular hydrogen, and so I'm happy to provide this education on molecular hydrogen and some of the research that I've been involved in. So first, I like to start with this because it's very important people understand what we're talking about. So first, I want to ask you this question. When you hear molecular hydrogen, what does it refer to? Is it the H in pH, or is it the H minus ion? Is it the diatomic gas, or is it D, the H plus cation? And the answer is C. That is correct. C is the correct answer. And maybe many of you already know this, so obvious, but this is too. If it's really obvious for you, then you're potentially in a situation where you don't explain that to people you're talking to. And I just recently, some skeptical scientist person was kind of debunking molecular hydrogen, and they made the error once again that it's thinking it's pH, it's like alkaline water or something, or it's the H plus cation. So this happens all the time. So for as long as people are going to make this mistake, I'm going to continue educating on this. And so I encourage you to always reinforce what we're talking about when it comes to hydrogen. But this is molecular hydrogen, right? This is the H2 molecule. In fact, to really explain this, there are different forms of hydrogen. And people think, well, there's hydrogen all over the place. There's already hydrogen in water. How is this already going to how is this going to benefit you? But you can see the images, the different chemical species of the forms of hydrogen in this diagram here, right? Where molecular hydrogen is two protons and two electrons. That's the chemical species. It's a neutral molecule. Then you have the hydrogen atom. That's what you see on the periodic table of elements. Like hydrogen is number one. That's the hydrogen atom. But see, that hydrogen atom with just that single electron doesn't want to stay by itself. It wants to react with other things. For example, it can react with another hydrogen to form the molecular hydrogen, the hydrogen molecule we're talking about. There's other forms. In the top, we have the different ion species, the hydrogen anion, where there's two electrons and a proton. This is not really stable. You can be using like an organic chemistry for like powerful reductions like sodium borohydride, it's called, or lithium borohydride. It's sometimes people talk about a hydride therapeutic effect, but it's nothing to do with what we're talking about. And then the hydrogen cation, or the H plus ion, that is simply a proton. That's all there is. Just the red dot in the middle of the plus. It's just a proton, and that's actually what pH is. And so if you have a lot of those in there, you have a very acidic water. But there's no electrons, so that's why there's no relationship really between pH and electrons at all, because pH has to deal with protons. Then, of course, as hydrogen compounds, you can see you have, like with water, you have the two hydrogen atoms that are bound to the oxygen molecule. So yes, there is hydrogen in water and in methane and hydrogen peroxide, ammonia, but those are totally different chemical species than molecular hydrogen. So it's important when you're educating people, especially if they're somewhat skeptical, have a little bit of background knowledge, that they understand what it is that we're talking about. Now, hydrogen does have a pretty neat story, though. It's kind of romantic because it goes back from the beginning of time, right? Like if you think about the model of the Big Bang, or the hydrogen was the very first molecule atom that was produced. It's it's literally the ancestor of all of the elements actually, because like the sun, for example, in stars, they'll actually take hydrogen. The gravity is so strong, they'll actually take hydrogen nuclei basically, and push them together and form all the other elements. So like helium, it's just process of nuclear fusion. That's literally what is powering the sun. And so everything came from there. And so hydrogen's been involved from the beginning of time. And interestingly enough, it's probably also involved in the genesis of life. we kind of think that maybe life started in these deep sea hydrothermal vents, like in the ocean, and hydrogen gas being produced, and it contains those two electrons, and so it's able to donate those electrons as an energy source, right? Because our body needs electrons. That's why we eat food. And hydrogen has those electrons, and this could have started or initiated the life itself. And then so it's like different bacteria, of course, they can consume and produce hydrogen gas, but then we have that evolution aspect of where we have the relation between plant and animal cells and bacteria, everything's kind of related, and hydrogen seemed to be very important in that entire evolutionary process. Even to the point of today, we still are exposed to hydrogen gas in our bodies when we eat a healthy diet and we have a healthy microbiome. We naturally produce hydrogen gas in our bodies all the time. So it's something that's already, again, just very natural to our bodies, and hydrogen just is involved from the very beginning and through every critical landmark stage that we can think of. Hydrogen was there. So there's this kind of a romantic concept of that as well. But because it was always there, it also helps to understand why it would have biological effects with us today. So if we look at like when we take hydrogen water, though, for example, just what we call the pharmacokinetics, like what happens when you drink hydrogen water. So remember that the water, when you take hydrogen gas and dissolve it into water, it doesn't change the chemical structure of water, like it's still H2O molecule, and the gas is just dissolved into the water, and and that's why eventually the gas will go out of the water, right? And it makes me think too, like with fish, for example, sometimes we'll bubble air into the water so that the fish can consume the oxygen because the fish are not able to get oxygen from the water molecule themselves, but they actually get it from dissolved oxygen that's in the water through their gills. And it's the same idea when you're dissolving hydrogen gas into the water. So the water just becomes the carrier of the hydrogen gas. So if you were to take, like, let's say electrolytes or other supplements and dissolve that in the water, then the water becomes the carrier for those ingredients. And in the same way, the water becomes the carrier for these hydrogen molecules. And in this graph, was just illustrating what happens when you drink hydrogen water. So on the y-axis, it shows the increases in the H2 concentration in parts per million. And so you have a baseline level around zero, and then it goes up, 30, 50, 60, even 70 parts per million. So it goes up a lot after drinking hydrogen water. And it does that on the x-axis. You can see it, the time scale in minutes. It's hitting that peak time in around 20 minutes or so. It depends on the concentration, the volume of water you're drinking, but it's pretty rapid. In fact, you can see once you drink hydrogen water, we can actually measure the hydrogen gas coming out of the breath within just a couple of minutes, really showing just how fast hydrogen gas is able to diffuse through the body and get to different areas. And because what has to happen for what is occurring in order for that to happen is that hydrogen gas it has to go through the stomach into the intestines and then diffuses through the intestines into the bloodstream, and from the bloodstream it goes to the heart and then to the lungs, and that's why you're able to measure exhaled hydrogen gas in the lungs because it's able to penetrate those tissues that quickly. Like I said, within just a couple of minutes, you're already seeing hydrogen gas in your breath, reaching that peak in 20 minutes or so. But then you also can notice that it goes back to baseline within about an hour. So that means that hydrogen gas doesn't store in the tissues. It doesn't like build up in the body or something. Like, some well, even some supplements, let's say like vitamin D, for example, vitamin D will store in your fat tissues because it's a lipid soluble molecule. And that's a good thing. It can be a good thing because that way during the winter when there's not as much sun, you still have vitamin D reservoirs in your fat tissues. It could also be a bad thing for if it, like way too much vitamin D, which is kind of hard to do. But maybe other supplements or other drugs or just toxins themselves, they'll build up in the tissues, and over time the concentration gets higher and higher and higher until it starts becoming toxic. Well, two important things with hydrogen is it's not toxic. Even if the concentration were extremely high, there's no toxicity that we've seen in any of the studies. And secondly, even if there were toxicity or someone had a concern about that, this graph shows that it doesn't stay in the body. It goes back to baseline within about an hour or so. So this helps also understand the safety of hydrogen gas and helps to mitigate some of the concerns about that. It also helps us to understand some of the mechanisms of hydrogen gas because we can see that the benefits of hydrogen gas last much longer than an hour. The benefits of hydrogen gas can last longer even when the hydrogen gas is not even in the body anymore. So, and we're going to talk a little bit about that and some of the mechanisms for why. We talked about hydrogen gas getting into the into the lungs and exhaled out. That's because hydrogen gas does have this what we call a high bioavailability. And this is a key aspect of any supplement, any drug, whatever it is number one, what is its cellular bioavailability? And when it comes to a lot of different molecules and drugs, there's a lot of barriers that it has to overcome. In order for something to provide any benefits, it has to get into the cell. In order to get into the cell, it needs to most things have to go through like a transporter protein, for example, because you know that cell membrane, as you can see in this diagram here, the cell membrane is this phospholipid bilayer, and it doesn't allow water soluble molecules to easily penetrate. And so it's just blocking water soluble molecules. That's why if you take a bit of fat or like oil and you mix it into water, they don't mix very well. And so it's hard to get drugs or supplements through the cell membrane. And the way that the cells do that is they use protein channels. And like you can see with the facilitated diffusion of this primary active transport, they'll actually have a protein channel that will allow specific molecules and proteins or whatever it is to enter into the cell that are specific for those specific molecules. And sometimes it even has to use ATP, the very energy currency of our cell. Sometimes it has to use ATP in order to transport those molecules into the cell. Whereas hydrogen gas doesn't need any of those things because molecular hydrogen is the smallest molecule in the entire universe. And that small size allows it to easily diffuse through the cell membrane. And it's also a neutral molecule. And that way it doesn't have, it doesn't have the repelling effect. So like water, for example, is also a neutral molecule, but you know that if you remember how the water molecule looks, it's kind of like Mickey Mouse with the oxygen and the hydrogens. And so it kind of has that oxygen a little bit has a slight negative charge to it. That is why water and oil don't mix. They repel each other. Well, hydrogen gas is just in this linear form. It's a nonpolar molecule, so it has no problem diffusing through the cell membrane. And again, it happens very quickly. As I said, and you can see in that graph, within just a couple of minutes, it's already diffused, you know, through the stomach, the intestines, through the intestinal wall, into the portal vein, the venous circulation, you know, to the heart. The heart pumps it then to the lungs, and then you're exhaling it out. And that happens within just a couple of minutes. So partly again is because hydrogen has such a high bioavailability, and that positions it and uniquely qualifies it as a really unique molecule for therapeutic effects. Now, a lot of people have heard these days about alkaline ionized water or electrolyte reduced water, and there is an important connection that you'll want to understand for yourself, and or if you're talking to people who are have these different water ionizer machines. And the fact is, the research started on this back in the 1930s in Japan, and then actually in 1965 they were approved by the Japanese Ministry of Health, Labor, and Welfare for use for human consumption. It was safe and it seemed to you know have certain effects on it. But really they got popular around in the 1980s, and a lot of testimonials started coming out where people were talking about this water all the time, and that's when some more serious scientific research began. And the question first was, well, what is responsible for this benefit? And initially, there was a lot of ideas about the alkaline pH of the water. And so many of you probably have heard about the alkaline craze, and you go to the grocery store and there's alkaline bottles and all this stuff, because a lot of people thought that, well, our bodies are alkaline, and so if we drink alkaline water, we'll be able to get alkaline benefits. But they didn't understand, you know, basic physiology that our the pH of our body is already very tightly regulated and it's easily regulated. In fact, when when you are to go exercise and you create and you make a lot of CO2, for example, that CO2 lowers your blood pH, and that is a stimulus for you to breathe more. And so if you hyperventilate, you can elevate your blood pH, which is why sometimes people who are like hyperventilating because of their anxiety or whatever, their pH actually starts to get too high, and that can cause some problems. So the pH is regulated so easily just by breathing a little bit more or breathing a little bit less. And it's a very important mechanism, but it totally refutes these ideas that just drinking alkaline water is going to provide benefits. It's not. And so the other ideas like microclustering or different structures of the water came up, but those didn't really explain the benefits either. But one thing to consider though is when you do electrolysis of water, as all of you know, the electrolysis of water is, by definition, is the decomposition of water to hydrogen gas and oxygen gas. And so you can see in this image here where we have oxygen gas being produced at the anode and hydrogen gas being produced at the cathode. And we can see that in the equation as well. Well, this is hydrogen gas. It's always being produced. And so it turns out that hydrogen gas is the responsible agent in this alkaline ionized water. We published this article a number of years ago, and it's not just a study, but actually it's a comprehensive review of pretty much all the studies that were done on alkaline ionized water. And they all demonstrate that when the hydrogen gas is removed from the water, the therapeutic benefits are eliminated, even if it had a high pH still or a high negative ORP or other factors about it. So feel free to, you can take a picture of this article or look it up later, but this article really helps people understand that it's the molecular hydrogen that's responsible for any observed therapeutic effects of the water. And I'll just add too that those machines were developed before it was known that molecular hydrogen was the therapeutic agent. And so they did not optimize these machines to make high levels of hydrogen gas. And that's why some machines are able to produce higher levels than other machines. Some machines are able to last longer than other machines in terms of producing the molecular hydrogen. So there's a lot of variables with this because they were never intended to be a molecular hydrogen machine. But see, now that we know that molecular hydrogen is indeed the therapeutic agent in this water, we can actually develop products specifically for molecular hydrogen. And that's where things get exciting once we understand the scientific research behind the potential benefits of molecular hydrogen. Then, if that is true, if those things exist, then we can develop products specifically for that. And so we can look at some of the benefits and research on molecular hydrogen just as a brief overview. This was a study published in Nature Medicine back in 2007, and it's really what ignited or exploded, no pun intended, the research on molecular hydrogen. And what they basically did is it was a animal model of a stroke, okay, a cerebral infarction. And basically, when you have a stroke, you don't have a blood supply to the brain for a certain amount of time, and that's going to cause a lot of damage because you don't have any oxygen to go into the brain. And then when you let the blood go back to the brain with all the oxygen, you actually cause even more damage because you get this burst of free radicals and reactive oxygen species and inflammation. So it's this what's called an ischemia and reperfusion, the damage that is occurring. And in this study, so they basically induced this stroke model, and they administered like helium gas for as a control, but then also hydrogen gas at just 2%. And you can see in these images here, so the 0% of hydrogen gas, you can see the white area of the brain. That's the dead area of the rat brain. And then on the 2%, you can see it still has a lot more of the red color. That is showing the protective effects of molecular hydrogen. And it seemed to work by reducing the amount of oxidative stress and free radical damage that would normally occur in these types of situations. And so this was a very powerful study that really, like I said, ignited this research and published in Nature Medicine, which is one of the top scientific journals that there are. And and so if we understand a little bit about some of the reasons for different diseases and problems and conditions, then we can understand better why hydrogen is so unique and interesting. I think many of you already understand that oxidation is indeed associated with aging and diseases, right? This oxidation can cause damage directly to our DNA, our RNA, our cell membranes, proteins, and it's linked to, the actual cell death and aging and pretty much every type of disease and condition, inflammation, cardiovascular, cellular mutations, neurological conditions, and so on. So it's like, okay, so if we know oxidation is causing that from free radicals, then we should just take antioxidants, right? We want to get rid of these oxidants and we can take antioxidants. It makes logic, right? In fact, that is why we have the free radical antioxidant marketing. It's a multi-million or probably billion-dollar industry with so many antioxidants out there in order to fight and combat this oxidation that's occurring. There's just one little problem with that. It doesn't work. In fact, the research shows over and over again that as we take these high doses of antioxidants, it not only has no benefit, it sometimes impairs and increases mortality and has harmful effects. In fact, like this, just this one study, because I like to do exercise, so I think about this. But these conventional antioxidants may actually negate the benefits of exercise training. And so just think about that, for a minute. You're decide your New Year's resolution. I'm going to be healthy, and I'm going to set my New Year's resolution. I'm going to exercise every day. I'm going to take my supplements and my gigatons of antioxidants and everything. And you do that every day, and so you're exercising well and you're taking all the antioxidants, but then at the end of, a couple of months, you're like, I don't have, I'm not, my glucose levels haven't gone down. I still, have insulin resistance and you haven't really improved your performance as much as you would have thought. And that is partly explained by taking these high doses of antioxidants. And so it's something to really consider, especially for athletes, if they're really trying to be at that top level, competitive level, they don't want to do anything that could potentially harm themselves. And unfortunately, they're also in a situation where they're trying to get just the smallest edge on performance. And so they're kind of willing to, if something kind of makes sense, well, yeah, I'm going to go ahead and try that. But it has to really weigh that with the potential downsides. And when it comes to taking antioxidants and even anti-inflammatories for athletes, sometimes it has the opposite effect of what they're going for because it can actually negate that. Well, well, then how do you explain this apparent paradox? We just barely went through and showed that when you have too much oxidation, too much free radicals, you indeed get all of these diseases and these problems and impairments. And yet, how come when you take antioxidants, you don't see really these benefits? And it is a bit complicated, and sometimes that's because these antioxidants never actually get to where they need to go because they're large, and they don't actually get into the mitochondria where they need to go, for example, or maybe like vitamin E is more of a lipid soluble antioxidant, so it kind of stays in the cell membrane, but doesn't go into the cytosol where other types of oxidative stress is occurring. Or maybe vitamin C, it does go into the cytosol, but it doesn't go into the membrane where other types of stress is occurring. And so you think, well, I take a combination, but then you have these other interesting redox interactions with each other at high levels where they start to interfere and become problematic. And so it's one of these issues themselves of just targeting the antioxidant and getting to the locations where you want it to go. But the other big point is that we actually need free radicals. We need ROS or what we call reactive oxygen species, okay? Because they're involved with so many important functions in the body, in like signal transduction, like how your cells communicate within themselves and to other cells, your immunity, right? I mean, most of us have probably been sick before. Thank goodness for free radicals because the free radicals produced by our white blood cells are end up what are able to kill the various pathogens and inactivate them. There's some crazy therapies people do. I don't know what I think about them yet, but like ozone therapy and hydrogen peroxide therapy, all of these are very strong therapies. But what are they? They're reactive oxygen species. They're strong oxidants, and it makes logical sense because we actually want these. You have like also blood flow. Nitric oxide is a big craze as well. And nitric oxide is a free radical by definition that causes your blood vessels to dilate. And if you got rid of nitric oxide, you would die quickly. So free radicals are very important. So they actually need to just be not eliminated, but need to be regulated, right? Not too much, not too little. And this is really then the differentiating factor of molecular hydrogen. So if you can understand the logic and everything that I've explained so far, then you can help explain and understand why molecular hydrogen is so different and is uniquely qualified to serve uh, for the cellular needs for that what we call redox homeostasis. And it really we can kind of boil it down to this idea here that life is like a battery. It's balanced between oxidation and reduction, okay? Um, Although technically it's not really balanced because if you have a battery that's balanced, then we call that a dead battery. It doesn't work anymore. So you actually don't want to have balance. What you really want to have is homeostasis, right? That's when you're able to keep levels of certain molecules in a certain state more than the other one. And so I guess we could change this graph a little bit so that we'd have like a little bit more reduction and oxidation, but you would still have both, okay? And that's homeostasis. And that's how your body operates is by maintaining this homeostasis. Not too much, not too little. And balance is a nice word romantically. It's just technically not correct. But it is kind of neat to think that life is kind of balanced like this between oxidation and reduction. And since we started this conversation with romance, we can continue with that. Because if we look at what the two molecules that characterize oxidation and reduction the most, well, on the one side of with oxidation, we have oxygen, and that is the oxidizer, right? That's the final electron acceptor in our mitochondria. It's a strong oxidant. And then on the other side of reduction, we have H2, we have hydrogen gas. And when those two molecules react together, you form the life-giving solvent, water. So water is kind of this perfect balance, if you will, between hydrogen and oxygen. And we obviously need oxygen to form water, but you also need hydrogen. And so I guess you could continue with this analogy just for philosophical purposes. Does that mean that we need oxygen to live, but we also need hydrogen just so we can, really reach our full potential? Philosophically, spiritually, yeah, it's okay, but scientifically, it doesn't make any sense. But that's another story. But it's kind of fun to think about. And here's another slide that I think helps illustrate scientifically this homeostasis balance. Okay, in this study here, what I like about what this figure illustrates is on the y-axis we have the concentration of OHDG, just say a marker of oxidation that's going on. Okay, and then we're going to give different doses of radiation, and we know radiation causes oxidative stress. It's going to cause free radical damage. And we see the very first bar chart, there is no hydrogen gas administered and no radiation. That's the 4 grays of radiation. So no radiation administered. And we see there's a slight amount of oxidation that is just naturally occurring at baseline all the time. That's what it does. And remember, we want to maintain a normal balance or a homeostasis of oxidation. If we were to reduce it further, like maybe conventional antioxidants at very high doses do, then we start creating problems. We don't want to perturb that homeostasis. We want to maintain redox homeostasis, not create redox dysregulation, which can occur with taking high doses of antioxidants and other types of supplements. So take a look at the next chart or bar graph. Well, in this case, no radiation was administered. That's the minus sign. So no radiation administered, but hydrogen gas was administered. And you can see, what does hydrogen gas do to that baseline oxidation state? It doesn't do anything. It just keeps it right where you want it, right where you want it to be. So if you're already healthy or maybe
these specific cells in your body are healthy, maybe these ones aren't or something, it's going to help to maintain the redox homeostasis in those cells, not going to perturb it outside of homeostasis where it could potentially be pathogenic or be harmful. But it's there to also prepare your cells in case an assault were to come. So in this next one, you can see the oxidation goes really high. In this case, only radiation was administered, but no hydrogen gas. And so, as you would expect, oxidation went really high because that caused a lot of oxidative damage and oxidative stress. And there was no hydrogen gas. But then when you administer both the radiation and the molecular hydrogen, you can see the molecular hydrogen largely attenuated or reduced the amount of oxidation that was occurring. So the take home, this is just a cell culture study, but the take home concept is that hydrogen doesn't eliminate the normal healthy free radicals, and it really only prevents excessive free radical damage. Okay, it's about helping to maintain redox homeostasis. That's the key about hydrogen, that it makes it materially different than conventional antioxidants. And that's actually why I don't even like to call hydrogen an antioxidant, because that suggests unidirection, right? That antioxidant, by definition, goes one way. That's not really what hydrogen does. It goes any way it wants to do. It's more an adaptogenic regulator for redox homeostasis. In fact, this is one of the mechanisms that hydrogen gas uses to provide its antioxidant functions. Your body has its own antioxidants naturally. That's how cool your body is. So you have things like superoxide dismutase or glutathione. Like these are your body's own natural antioxidants, and they're regulated by your body so that ideally you have the right amount. But of course, with different toxins and problems, those levels can go down more than they should, even with aging. And so by eating good foods, by exercising, having a healthy lifestyle, it can help to maintain your body's natural antioxidant enzymes. Well, this is important because, and it happens because of this activation of what's called the NRF2 pathway. And this NRF2 is this transcription factor that it's like a little protein that, when it gets activated, diffuses into the nucleus where your DNA is at, and it binds onto the DNA and to this portion called the ARE, or the antioxidant response element, and induces the transcription of your body's natural antioxidants. And in fact, this NRF2 pathway regulates over 200 different cytoprotective proteins and enzymes. And wouldn't you believe it, molecular hydrogen is also able to activate the NRF2 protein. And so this is one way that hydrogen is able to maintain that redox homeostasis, because it's helping your body and your cells do what it already does. It's just helping to maybe optimize or work with the tools your body already has. And that's why we're not pushing things too far one way or the other. And so maybe some cells, they don't need enough regulation of NRF2, so hydrogen gas won't do that there. But other cells, maybe they could get a little boost, and so hydrogen could help in those cases. So this is, again, something that's different from hydrogen, because in other antioxidants, they don't have this effect to be able to upregulate the NRF2 pathway. And now when we start seeing benefits in like mechanistically, we can start seeing benefits like in animals. I showed you the one with the stroke model. This one is just an interesting one because a lot of people these days, they do suffer from what we call obesity, being overweight. And it's a difficult situation, because when you're obese, you have a hard time wanting to do caloric restriction and wanting to exercise and everything. And hydrogen seems to actually mimic some of the effects of caloric restriction for several different reasons. But in this study, it was interesting because these two rats here, they were fed the same diet, and but one group drank hydrogen water and the other one didn't. And so you can see the one on the left is a little bit thicker than the other one is. And it was just the difference in drinking hydrogen water. And this was equivalent to around a 20% caloric deficit. That's crazy. That's insane. That it was that big of a difference. But it was. And of course, this is an animal study, and they were also leptin deficient. And so you have to be somewhat cautious how you translate this to humans. But it does suggest a mechanism that that it has these possible effects. And in this study, they also found that it increased FGF21, which is fibroblast growth factor 21, which is a hormone produced by the liver, and it helps to increase energy expenditure. And so maybe this could account for some of these effects that we're seeing in the study. But there are some clinical studies also showing weight loss. In fact, that's one of the interesting things with the hydrogen water studies when it comes to like metabolic syndrome is it does appear that on average, just drinking the hydrogen water, there appears to be a loss in body weight, typically fat mass, and maybe even an increase in lean muscle mass, or just lean mass in general. This was a study that I was actually involved in a number of years ago and looked at the effect of 24 weeks using a high concentration of hydrogen-rich water on body composition, blood lipid profiles, inflammation biomarkers in men and women with metabolic syndrome. This is a randomized controlled trial. We had 60 subjects in it. And basically we found that hydrogen water decreased inflammation, oxidative stress, and body mass, and improved cholesterol levels. And so it's interesting that both the animal research shows this, and a number of clinical studies are showing this, and then just anecdotally, there are a number of stories I've heard of people where they are wanting to lose weight, but it's difficult for them. They start drinking hydrogen water, and they're able to just lose weight easier, but also it's like they have more motivation to maybe exercise, start doing things. So that's going to be a confound per se, but also that's exactly what we want. We want people to take control of their own health and start having better healthy habits. And so when you are educating people about molecular hydrogen, I think it is a good idea to encourage them to eat healthier and not having the sugary drinks and things, and to exercise more. That seems to be an important part of hydrogen. And maybe it's just my philosophy a little bit is, hydrogen wants to help you, but it'll help you more if you're helping yourself. And if you aren't willing to exercise and try to take care of your sleep and try to do these things, this hydrogen will be there maybe to support you. But I just tend to think that when you're taking your health in your own hands and you're trying to do better on your own, there's almost like a synergistic effect where the effects of hydrogen become more pronounced. Okay, so just an idea that I have. Now this study is all. I talked about those pharmacokinetics earlier. We talked about how like the benefits of hydrogen last even though hydrogen gas is no longer in solution because it's gone like after an hour. This is a really good study in cell culture that really helps to illustrate this point. And on the y-axis, you look at this NAD plus NADH ratio, and of course you want to have a high ratio just for normal cellular metabolism. And then you have different groups, right? So there's a control group, and you can see from 0 to 48 hours, it's all the same. It's just a control group. That's what you expect. It's normal. And then you have this other group, which is TCDD. And this is a toxin. It's an environmental toxin that we can be exposed to. And you can see that after 6 hours and 24, 48 hours, that ratio just started to decline more and more, and showing this is one of the problems we have with this toxin. And then the other group was just hydrogen gas. Again, it didn't really do anything, just pure hydrogen, because the cells were already normal. They were healthy. They were already okay. So you don't want to push things in either direction. You want to maintain redox homeostasis, because NAD plus NADH is all about redox, right? That's the transfer of electrons. So H2 group, nothing happened. That's great. But then when you combine the two, you can see that hydrogen largely prevented the decline in that ratio. And you can see from 0 hours, 1 hour, 6 hours, and 24 hours, it's still maintaining that ratio. And then at 48 hours, there was a decrease. But what's interesting is this is just a petri dish, okay, a cell culture media. So the hydrogen gas was only in there, it's probably all gone within 30 to 60 minutes. And yet it was able to provide this protective effect for even 24 hours. So maybe you should drink hydrogen water every day. And even though it's not in your system all the time, that's okay, because it's influencing how your cells operate, the gene expression, the NRF2 pathway that we talked about, a number of other things to give you a protective effect, a residual protective effect. Okay, and another couple of points that I think are important these days. This one is with autophagy. I think many of you are already familiar with this, but this autophagy or autophagy is just this process of clearing out your dysfunctional and cellular components. And typically, if you're not eating food, if you're exercising, you get this autophagy, and it's important because it's going to help lower inflammation, help to lower oxidative stress, and you get more energy from improved mitochondria because you also have mitophagy occurring as well. It's also neuroprotective and so on. And it's promoted, as I said, by exercise, caloric restriction, and yes, hydrogen. So if you look at like this study, for example, hydrogen-rich saline mediates neuroprotection through the regulation of endoplasmic reticulum stress and autophagy under hypoxia, ischemia, neonatal brain injury in mice. But I just want to point out that molecular hydrogen exerted neuroprotection by what? By increasing autophagy. Okay, so it increased autophagy when it was therapeutic. However, look at this. This was a myocarditis of the heart ischemic perfusion. Hydrogen protected myocardial ischemic perfusion injury in rats by downregulating or decreasing autophagy. And I want to bring this up because we don't just want autophagy everywhere. Autophagy for you, autophagy for you, everyone gets autophagy. It's not necessarily the best idea because we can get what's called autophagic cell death, where we get too much of that. We want to have it be regulated, and we only need as much as we need. And hydrogen is a regulator; it's a master regulator, and that's why I used that term earlier. It's kind of more of an adaptogenic regulator, and that was true for the inflammatory response, for the antioxidant, redox, oxidant response, as well as that goes down to things like this with autophagy. So just another example of how hydrogen is there to help maintain homeostasis, not push things in one direction or the other. Because the number one question that we often get is when people learn that, oh, hydrogen is able to help lower blood glucose levels, and automatically it's, oh, so I'm going to get hypoglycemia and I should be aware I shouldn't have this, or hydrogen might help lower blood pressure. Oh, so I'm going to get hypotension and I'm going to get lightheaded and pass out and I'm driving and then die and then maybe they're not that far. But as you can consider, there's all these concerns, but over and over again, the data just suggests that it just helps to really help to maintain homeostasis. And these are just some of those examples. And same thing with like the nervous system of the body itself. This is just drinking hydrogen water, and these are healthy patients already, actually. But they drank hydrogen water, and they found that the sympathetic nerve activation was decreased by hydrogen water. So it seemed to improve your mood, anxiety, and your autonomic nerve function just in daily life. And I think a lot of people have already experienced some of this, where they're trying hydrogen water and they just feel a little bit more regulated or something. And maybe this study here helps to demonstrate that. And some of those mechanisms we talked about before also illustrate why it's able to do this. Now, this is a big publication. I'm just finishing up some of the mechanisms here, but I posted this to my social media as well because it's really exciting. As I said, I'm excited to finally announce that the article we've been working on for over 10 years has now been published. This is really exciting, and it really helps to explain the mechanisms of molecular hydrogen a lot more. Because we found that this RISC-A iron sulfur protein, or RISP, acts as a primary target of molecular hydrogen. So what happens is your mitochondria, right? As you know, that's the energy powerhouse of the cell, and you have one of the main things, we have what's called the electron transport chain, where you take electrons down this chain, and then it ends up connecting with oxygen, and you form water, and you make a whole bunch of ATP. But in that chain, you have one complex called complex 3, and it has this specific protein, this RISC-A iron sulfur protein, and it carries one electron at a time. And so I memorized this because doing one electron at a time is kind of dangerous. It's kind of risky, actually, and that's the RISC-A. That's not the connection. It's the guy who discovered it, but I thought it was funny. Anyway, so this RISC-A iron sulfur protein seems to be targeted by molecular hydrogen, and this is interesting because what happens is hydrogen almost like slightly toxic. It actually suppresses this protein's ability to act normally, just a little bit. Okay, so it just suppresses this, and then the mitochondria is like, whoa, this isn't good. I'm losing ATP levels. I'm losing my membrane potential, and it starts producing more free radicals. So we actually found that hydrogen increased free radical production just a little bit in the mitochondria. under that short time scale. So the mitochondria, recognizing this is no bueno, it starts to upregulate other protective enzymes and proteins, and it induces what's called the mitochondrial unfolded protein response, which helps to improve the mitochondrial function. So then you end up getting a regeneration and rejuvenation, basically, of the mitochondria. And now your mitochondria is back up to working, banging on all cylinders now. And so this might help us to understand more directly and precisely how it is that molecular hydrogen is able to act as a regulator, because it's targeting the mitochondria, and the mitochondria regulates reactive oxygen species, the free radicals, too much or too little. It regulates all of those that are ATP production. So many things are regulated by the mitochondria, and hydrogen directly targets a very key protein in the mitochondria. So this is a very exciting publication, and it's published in Redox Biology, which is a big deal. There's a lot of publications, and I say it not to like, oh look, I published in this one, but I want to illustrate only because there's a lot of journals these days that will publish pretty much anything. You could have AI write any paper and then submit it to a journal and they'll publish it. And if you just pay the money, it's like a pay to play, and that's not how science is supposed to work. It's kind of unfortunate. But Redox Biology is a very well-respected journal, and so any real scientist skeptic will really look at this and be like, wow, okay, this is really powerful. I've had a lot of really good experience with this. Just actually yesterday I was at the university, and we have a new faculty member. He's top scientist in his field and things, but he came from a different university, and we were talking about some of the things that that he did, and then he asked me questions about, what do I do, what I'm involved in, and I brought up molecular hydrogen. I'm just waiting for his skepticism, and I'm like, what? Who is this guy? Like, what are you talking about? What a scam, right? But I was just explained a little bit about hydrogen gas. Like, first, make sure he knew what it was, right? It's not a hydrogen ion, it's not the pH. And then he was interested. And then I brought up this article that we published in Redox Biology, and he was like, oh, dang, that's a top journal. He was really impressed, and so it made me feel good inside. And I was like, oh, okay, that's good. Anyway, just a little anecdote story with that. I'm just really happy and honored really to be part of this publication. And my colleagues in Japan, they're the real people who did a lot of the work on this. I'm just grateful that I was able to be part of it and help to put this together. Okay, now, I just want to kind of summarize everything, because hydrogen is able to help with so many things. So this is kind of like a summary slide a little bit. Hydrogen and caloric restriction are like two things. Like caloric restriction, can do so many amazing things, and they work in so many similar pathways together, because both hydrogen and caloric restriction can help with like autophagy, NRF2 activation we talked about. That goes on to the DNA repair. And then you end up getting actual benefits like the anti-aging like effects, or decreased inflammation, or weight loss we talked about. So it's kind of a way to maybe explain the effects of hydrogen, and it kind of mimics these paths of the caloric restriction. So now we understand the science of hydrogen, right? Like all of its benefits. So the question from the beginning was, well then, okay, now that we know hydrogen is good, how do we get it? Like, can we develop products or something where we can really get the benefits of molecular hydrogen? And to Patrick, to your point, you can learn this information through those MHI courses. All the things that we just talked about, you can actually become certified through MHI, which is a nonprofit organization, and it just goes through the basic chemistry and principles. And I know none of you have done that already before, but I do encourage you to do that, because there's even like little elevator pitches and things in there for people to just grasp the concepts, so they can explain and know what to say and maybe what not to say. But I want to talk about this, though, the Luma bottle that Taryn Luvite had been putting a lot of work on, and I'm excited about this. And I just want to give you my impression, my thoughts, and why I think it's a great innovation in the industry. Because, as you know, everyone has like the current bottle, like the cell power bottle. It's great. You get a therapeutic level of hydrogen. People have a lot of benefits from it, and so on. But with all bottles, there's always different concerns with how the user is using it, right? Like, what is the type of water you're putting in? What's it going to do to the membrane? What about electrocuting the water, let's say? What about contaminants and so on, right? Well, this bottle is a complete dual chamber bottle that completely separates the electrolysis portion and the drinking portion. So they're totally separate from each other. So you do electrolysis in one chamber using distilled water. Because if you look like at DuPont, all the membranes, all of them out there that are protein exchange membranes, all of them actually require you to use distilled water. But we don't really want to drink distilled water. Okay, but if you don't use distilled water, you will damage the membrane, and over time it just gets worse and worse. So in this case, because of the different chamber, you can put distilled water in there, and that'll make the membrane so that the PM won't ever get mineral buildup on there, well, because you're not ever adding any minerals. And the other big thing that'll damage bottles over time is when they dry out because you drink all the water and then you set it on the counter and it's in the sun, it gets hotter, and then the membrane just dries out, and it's no bueno. In this case, you can put that distilled water in and it just stays in there. So the membrane is always wet. So maybe you forgot it at home, or you go, you're gone for a while. The water is still in there. The distilled water is still in there, and then there's no concern with bacterial buildup or this kind of thing either, because again, it's distilled water. There's no contamination. But more than that, you make the hydrogen gas in that bottom chamber, and then it diffuses into your drinking water, your liquid solution, and you can put anything that you want in there. So there's two benefits right there, because the liquid, the other chamber where your liquid goes, your water, you can choose any liquid that you want, whether it's like tea or coffee or milk, any type of water you want to drink. You can have different electrolyte powders or whatever. I know Lumidia is coming up with some really cool supplements they have in play that can work synergistically with the Luma bottle, and with the hydrogen, for example. You can just put that in there, and you can infuse your special concoction with molecular hydrogen, and you don't worry about harming the membrane or the electrodes or anything like that going on. And so this really is a major innovation when it comes to all the other bottles that are on the market. And then there are people who are concerned about, oh, what about contaminants from the membrane or the electrodes, or the water getting electrocuted or something? Well, that whether those concerns are legitimate or not, and of course some of them are, it's not an issue with this, because they're totally circumvented by this totally new design, because the hydrogen gas is produced and then diffuses into a different portion of the bottle, just diffuses right through it, and then you're able to infuse the H2 into any liquid that you have. So that I just want to say that. Hats off to Taryn and Vite for working on this, for putting this together, and basically innovating on this type of thing. That's very exciting, and I think it makes a major milestone in hydrogen technology development. So that's really, I'm really excited to see the bottle myself. And it's about time. This is coming in a good time, because if we look at this graph here, we have the awareness and acceptance, and then, it kind of shows some of the years. So research in 2007 when it started, and in 2013 I started MHI, and I said in 2027 will be like an inflection point, which is perfect timing when it comes to this Luma bottle and everything you guys are doing, because you guys just spread this education out to everybody, and then we're going to really see this inflection point where everybody's going to be learning about hydrogen. And so I predict that by 2037, hydrogen will be widely recognized as a therapeutic gas. So I'm very excited about that, and I think that you guys are going to really help to make this prediction come to pass as well. So with that, I just want to say thank you for your time and your attention.
Awesome. Thank you so much. I appreciate everyone sticking around and listening to those insights. Huge. And obviously, as we grow and continue to do these science calls, we're going to be bringing Dr. LeBaron on to really discuss a lot of the new innovations that he's seeing and he's researching around molecular hydrogen. And I'm glad that we tied in, obviously, some information and his thoughts on the Luma bottle, and we will be doing that more and more. Before I let everyone go and we end the call, I wanted to give a little bit of a shout out, because I know that we're going to be having a call this evening. And Genevieve, are you here? I think you are. There you are. I wanted you to give a brief little closing on your call tonight, and obviously what you and Carol are going to be doing. I'll go ahead and share the link in the chat with a little thumbnail of your guys' meeting tonight. So why don't you go ahead and give us a little update?
Hey, Patrick, I'm gonna just jump off because I gotta get down to the university here in a little bit. So I just want to say thank you, everybody. You guys are great, so appreciate it, and love to you all. All right.
Thanks, Tyler.
Bye.
Well, how exciting to be able to deliver this call tonight after that amazing training with Dr. Tyler. We're so excited. And Carol and I tonight are going to bring the fire that we brought back with us from Costa Rica, really sharing about this global and North American launch of Lumi Vitae to the masses. We're going to be talking about the new Luma bottle. We're going to be sharing the big vision of Lumi Vitae, sharing Taryn's vision, and bringing our heart into tonight. And so I would say this is going to be an amazing call for your prospects to really be in the know, be in the energy, the frequency of Lumi Vitae and the bigger vision, get to know the products from Cell Power, LVIQ, and the Luma with the Founders Pack really being talked about at the end. And of course, anyone who's on the fence about going from customer to brand partner, invite them to tonight, because I promise you that they're going to walk away with a clear understanding, a clear pathway, and a clear vision of what we're doing here all together. So it's my honor to be sharing this with Carol tonight, and we invite all of you to come and invite whoever you would like, and it's our honor to host you. So thank you so much, Patrick.
Of course, thank you so much. The time is 5 p.m. PST and 8 p.m. Eastern Time, 7 p.m. if you're in Central Time Zone like me. But be there or be square.
Exactly. And people are asking how long. Our goal is always 30 minutes, but I'm assuming 30 to 40 minutes max, just so that you guys know the timeline.
Awesome. So save the link. I put it in the chat below. Also, reach out if you want more information or want to bring somebody. Go ahead and spread that on social. Thank you so much for staying. I know the call went a little bit over, but I think it was super informative. And thank you very much for joining today. Have a blessed rest of your week and have a good night or evening.